start. So if that is the drawing that has been given to you, and this is a round pipe and this is a round pipe, this is pipe A, this is B. The examiner is asking you to develop both pipes. So we need to open. Development means that open the pipes before they were rolled into round shapes. How were they looking? They were like flat sheet of papers. So after that they rolled them into any shape. It can be hexagonal pipe or round pipe or square pipe, but these are both round pipes. So I want to develop A and B. So to develop, you can either develop straight on this drawing or away from the drawing. The easiest method is to develop on the drawing, on the page here, than away from the interpenetration. It's very easy for you to develop on the interpenetration. I'm going to develop, let's start with B, okay? To start with B, make sure that you focus on this edge. You see here, because this is the circumference. Do you know this is the circumference of the pipe?
Yes.
That is the round part of the pipe. So the round part of the pipe is the one that we draw a line from, and the line straight like that at an angle. Let's say if this angle is 60 degrees, you are going to draw this line, and this line, because the pipe is a round pipe, the length of this line, you can start from maybe here. I'll start marking here, but this will just be the construction line. So I'll go down. I don't know if you're able to see.
No, you're going off the screen there.
I'm getting off the screen. Okay. Fine. So I'm going to end somewhere. What I want to do is I'll start here. Then the length until maybe here should be the circumference of the pipe. You know, circumference means you unroll the pipe and
yes.
It's no longer a round pipe. It says, flat sheet of paper.
Yes.
So this is the length of the pipe when you open it. We call it the circumference, and it is always equals to pi times diameter. Okay? So diameter is the diameter of the pipe. So if I give you example that this diameter is diameter 40. So you're going to say pi times 40, then whatever answer you get, let's say it's 112, example. This is the length you're going to mark here, okay?
Okay.
Then once that has been done, you need to divide this length, this circumference in 12 equal divisions. How do we divide a line in 12 equal divisions? You start from here. At that angle, at that point you draw a line at any angle. You hear me? Any angle.
Yes.
Then, this line you have drawn, divide it in 12 divisions. 1, 2, 3, any space of your choice.
As long as it's equal spacing.
As long as equal spaces and there are 12 divisions. Why do we divide in 12? Because that circle is 12 divisions.
Yes.
Okay, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 until the last one, which is the 12th point. You need to connect this last point to the last point here where the circumference ends, this one here. It depends where it's going to be. Now it looks like it's straight. Sometimes it can be at an angle, as long connect the last point with the last point of this circumference.
Okay.
Then you are going to draw parallel lines now. The lines parallel to this very line you have just drawn. This will always be the first line you have to draw. Last with the last with a set square. So what I'm saying is it's not going to always be straight. Sometimes it will be coming like that. If this point was down here, you see.
Yeah.
So any angle the line is sitting at, you draw on each and every division parallel lines. So let's say these are the parallel lines. This method is in chapter 1. You need to make sure you go to chapter 1 and see how to divide the line in 12 equal divisions. So these are the 12 divisions, and once that has been done, from each of these divisions, you need to draw perpendicular line to the circumference. You hear that?
Yes.
So the circumference is sitting at that angle, so perpendicular lines will be going this way, straight. You do this. Meaning that you are developing exactly on the interpenetration than away from the paper. If you do away from the paper, it will be time consuming. I'm going to explain with B. Okay, so that has been done. Now when we come to pipe B, because this development is for pipe B, you have to say which between this edge and that edge is your joint. You need to tell the examiner to say, I'm opening my pipe maybe on this edge, or I'm opening on this edge. There can only be two edges or joints where they weld. You see, it's a seam. They can either weld here or weld there. So let's say we have numbered this circle. This is number 0. Then 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, back to 6. So you either open at 0 or 6. You hear me?
Yes.
So if we choose, we usually choose the short one. You see the short one? 0 is the short one than 6. 6 is the longest length of a pipe. Can you see?
Yeah.
Why we do that? Because you know it's cost effective. To weld a pipe with this length will cost you less money than to weld a pipe with this length. So your joint, let's choose this one. If examiner hasn't given you, you choose. So I'm pointing that as my joint. So we are opening at number 0. If your joint is on 0, you start numbering this circumference with 0, then 1, 2, 3, 4, 5, 6. Then you end with 0, 1, 2, 3, 4, 5, 6 will be the middle line. You see this line here?
Yes.
Is your 6. So if ever I decided to open here, if the examiner said your joint is here, then you start numbering with 6, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, back to 6. So that when you fold them, they meet and then you weld. 0 and 0 will meet and then you roll into a round pipe. Clear?
Yes.
Now we have to do the development. This edge here, this edge that you see here, it should be a solid edge. So here you need to outline, make it dark, make it dark. The rest is construction lines. Now, how do I get this part of the interpenetration on the development? You come to the interpenetration because you are opening at 0. Make sure that parallel to this, you see the way this is coming. You come here to point division 0. This is division 0. You need to come straight like that. Parallel to that. Can you see these two lines?
Yes.
Parallel to each other. So from point 0, this interpenetration point there, draw a faint line. It's a construction line. And because this point is 0, it must meet with 0 here and they meet here. And another one there. Let's make it, another one there. You see, 0 with 0. Where this 0 meets with that 0. Also where this straight line 0 meets with this line 0. It's here and there. 2 points. We go to number 1. This is 1 and 1. You can see 1, 1. So you need to number clockwise and anti-clockwise, same numbering. Then I come to this point here. You see this interpenetration there. That one is number 1. So I'll draw a line parallel to this one, but straight like this. And where it meets with this one, it's here. And where it meets with that one is here. Okay? Then we go to number 2, interpenetration 2 here. This one here. You can see 2. So when you come with 2, but what you need to know here again, that I'm forgetting to explain, is this one. Can you see this one is together with 5? Look here.
Yeah.
It's 1 and 5. So this line here, when you mark on 1, you also have to mark on 5 because it's the same point. 1 is behind, 5 is in front. When I mark 2, I'll mark 2 and 4. 0, you mark 0 with 6, but 6 you see at a point where it falls. It's a bit lower. So I've marked that one. Or you come to this one. This is number 2. When you come with 2, it depends. 2 will pass through number 4 here. Then 1 passed through 5. When you draw nicely, 1 will pass through number 5. Yeah, it passes like that through number 5. That's why I marked it on 1, 1, 5, 5. When I come to this point 2, it's gonna pass through 4. Then you come here, you mark on 2. You come here, you mark on 2 and 4. Same here. Can you see?
Yes.
Then you have this one, number 3. This is 3. You draw a line, and there is 3. Here, and there is 3. There. You see that there is 6 here, which is somewhere there. 6 is on its own. It's not going to be that 6 is with 1. No. So you need to come and draw a line from 6. But that line should be somewhere here. Can you see? For 6.
Yes.
You need to come exactly on the interpenetration of 6. And then it's going to be looking like this when you open. Freehand sketch, you use or a flexi curve. I'm plotting just the points. You see the way I've done it?
Yes.
Then only outline the outer edges, because this is not a hexagon pipe. Don't outline these lines here, no. If it was hexagonal pipe, I was going to outline the edges. You know, it's 6 sides.
Yeah.
Now this is only the outer edges that we outline. This is development of pipe B. And we are not using a ruler here. It's curved, because it's a curved interpenetration there.
Okay.
But if this pipe and this pipe were not round, or none of the two were round, then this I was going to connect with a ruler, you see? With a ruler, because maybe this is a square pipe to hexagonal pipe, then you connect with a ruler to get the development. Clear?
Right.
Okay. Now, to develop A, because I don't have space, I'm going to develop it here. You see the way I'm going to go. This side.
Sorry, ma'am.
Yes.
Lodewijk, your mic is very, very dull. Just put up your volume or put it closer to your mouth.
Can you hear me now?
The volume is not. Yeah?
Alright, how's that?
Yes, that's better.
Alright. Sorry, I'm a bit late.
I was wondering where you are. I don't know. Did you see what we did here?
Yes, that bottom section there you did basically is a template when you do the fabrication of the.
Yes, that is the one. So I've developed pipe B, and I was just explaining to say it's better you develop here on the drawing. Once you finish the interpenetration, they want you to develop. Though this line doesn't look like straight, make sure that when we draw this, and when you draw this line here, it needs to come straight, you see?
Yeah.
Nicely, perpendicular line. So this, we can make it this way, so that you see.
Yeah.
90 degrees.
Because that
The
will be,
distance from here to here is the same there, you know. And the numbering, make sure you use this method of dividing the circumference. You were asking?
yeah, basically that bottom piece, section B is that's going to be on a piece of paper that you just wrap around the pipe, and that's how you do a template with it. And then you cut it, and then you make it to fit in the pipe.
Yeah. Remember, you have to tell the examiner which is your joint, this one or that one. You know, we either use this or that. So I've already explained why I chose this as a joint. We go for a shorter one for the fact that it's the one that is less costly. When you are welding, you're not going to spend a lot of money on the welding rods, because it's a shorter joint than you choosing this longer one. You spend more money here than there. If examiner hasn't given you a joint, you have to show him which one you're using as a joint, and you always choose the one with a shorter seam. It's a seam.
Yes.
Yeah. Now, the next question is develop pipe A. To develop pipe A, we also look at the base, the circumference. This is the round part of this, the pipe. So what I'll do, I'll just project from here, this way, straight, parallel to the base of the pipe. And then I'm going to say from here to there. Are you able to see?
Yes.
Okay, pi diameter, pi d, circumference. This will be my circumference. So if this pipe is 50, I'm going to say pi times 50. Then I get that length. Then I need to divide this length into 12 divisions using this method. You can say 1, 2, 3, 4. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, like that. Join the last point with this one, and then you're going to have this. You're dividing the line in 12 divisions. And then once that is done, you draw vertical lines, meaning perpendicular to the circumference. And then you must choose for me which one will be our joint, between this one or that one.
Sorry, this is for you. This one here at the bottom. Are those millimeters? Those measurements you make there at the bottom. Alright? Are those millimeters?
Are you able to see?
Yes, I'm able to see.
Okay. So I'm saying we need to choose the joint.
Yes.
If I choose the joint here, remember this will have a circle here, you know. So if we choose the joint here, it means that we are going to see a hole here, you understand? Because that's where you are going to open from. There's a hole here before this pipe came in. They first, you know, opened the hole, then they came, fit the pipe and weld around. And then if I choose this edge here, it means that I'm going to open here. There will be a flat part. If we open here as the edge, you see a half here and a half there. If you choose this part as your starting point, you start with a solid line and a solid line, and then you end with a hole in the middle here. So whichever we can choose, let's choose this one here. I'm going to choose this as my joint. If I choose this as my joint, so let me say there is a circle here. If there is a circle here, round circle there for this pipe, okay, like that. Then I choose this number, maybe number 0, 0, 1, 2, you know, 3, and so forth. It means you are going to start with 0, and then you are going to end with 0. So it's 0, 1, 2, 3, 4, 5, 6, then 0, 1, 2, 3, 4, 5, 6. I really have to divide this circle for you to see. I'm going to draw it in blue. Don't mind what is happening here. We are not allowed to go through this. I'll draw this circle here. I know why I'm doing it. So if this circle is like this, then your divisions, 0 is here. You know, I'm opening here on 0. Then the next one is 1, then 2, then 3, 4, 5, then 6, then it's 0, 1, 2, then 3 in the center, then 4, then 5. So let's just ignore this piece, you know, we already developed. Fine. I want you to focus on the interpenetration. 1, 2, 3, 4, 5, 6, 7 points. Can you see the 7 points on the interpenetration?
Yes.
Those points, where are they falling here? On which divisions are they falling? Because if I do this edge here is in line with 0. Do you agree?
Yeah.
Okay. Then one division 1 is here. Division 2 is here. Division 3 is in the center line. Then it's division 4. Maybe division 4 is coinciding with this. Can you see that point?
Yes.
I'll call this interpenetration A. Or we can start with this one, A, B, C, D. Then C at the bottom in line with C on top. B and B. Then this is A on top, A at the bottom. Can you see what I'm doing? This and that, they will be in the same line because it's what? You can see 0 and 6. Then B here will pass through B here. C here, C, then D. As long as this pipe is not offset, you hear what I'm saying? As long as these two pipes, they are not offset, then A will be below A, B and B, C and C, then D in the center. But if this pipe was an offset pipe, I wouldn't do what I'm doing. They are going to fall on different positions. Okay? Now, where is this D falling? Coincidentally, D is falling on division 4. Can you see? Straight on 4. So what we do is when we come here, on division 4, here, you are going to write D for me. Interpenetration D. On division 4, put D. Then let's go to C. You see this C, division C. You come straight, perpendicular to, straight down here through C, straight down. Can you see where C is falling? Before 5. It's falling here, just before division 5, before division 5. So from between 4 and 5, I've got this C, division C. This is D, division D is on 4. Then I've got C. When I come here, between 4 and 5, the main circle is divided in numbers. Then the interpenetration, I number them with A, B, C, the alphabetical letters. Then I need to know where these alphabetical letters are falling on the numbers, whether between numbers or on the numbers. So C, when I bring a line down, is falling between 4 and 5. I take a compass. You take your compass from 4 to C before 5. 4 to C with the compass, or even here 4 to C. Then you come here before 5. You put on 4 and mark C. And here 4 to 5, you mark what? C. Then you draw a line, construction line. Are you understanding what's going on here? That's where the interpenetration is falling. This interpenetration is not falling on the divisions. The only one, according to my drawing, that has fallen on the division is D. Because when I came straight down, it fell on 4. And then I marked the green line on 4. Straight on 4. Okay? Then let's go to B. You see division B. B and B. When you bring the line straight down through B, it's falling on 5. Coincidentally, it's falling on 5. So meaning 5 is part of the interpenetration and 5. What is that? B. So you're going to say B. 5B. The last one is A and A. Already A and A, if you come straight, you see where it's going to fall. Okay? It's going to fall on 6 then. Can you see? Because that is the edge of the circle. A is falling on 6. So when I come here, this is A on 6. The rest of the lines we are not even supposed to include because the whole is just going to be here on the green lines. That's why I'm using a different color for you to see nicely. This you have to do as long as the examiner is asking you to develop a standing pipe and the diameters of these two are not the same. You have to do what I've just done. Now, how do we mark the points on the development? The first thing is, you know the edge here is solid. So, you need to outline from 0 to 0. This should be a thick line. That we know. Because it's the bottom. And the top is not affected. Also will be solid. So I'm going to outline the top of the cylinder. The edge, we are opening on number 0. So the edge is solid. Can you see on 0? It's solid. So 0, you close. Okay? We close, we close. That is the cylinder. Because we opened here. If ever I opened here, I was going to see a half and a half. And these green lines, I was going to mark them somewhere on the edges here. So let's start marking now. I'm going to start with A, then B, then C, then D. Okay? To mark A, come with your compass. Put your compass here at the corner of the pipe to A here at the, from here to here. That distance, you must take that distance here. That distance or projects from point A here. There is A here on the development. There is A, not this one. A here with A, where they meet here. Because this is A. I didn't open here. If I opened here, I was going to start there, but that's wrong. You must open at A, where they meet with A. There is another A here. You project. Where does that A meet with the A here? The A on 6 is here. 2 points. 1A, 1A. Project, then with A. Project, then with A. 2 points. We are done with A. Then go to B. There is B here, and there is B here. There is B. There is B here. Okay, the next division. Where was B here? There was B here on 5. So there is a point here. There was B here on 5. And then the same point, you go up. Can you see? 5 was coinciding with B. So I marked there B. So the B here must meet with those 2 lines for B. It's here and there. Next is C. There is C here and C there. There is a line and there is another C here. Then where is C? C is here, C is here. So where it meets with that C is here and there. When we come to this other side, it's C here and C there. You can see the circle is forming there. C is done. The last point is D, which is the center. That is D. Where is D here? D was marked on number 4. So it's here. D was marked on 4. There is D. Now you are going to plot freehand. There is a circle. You can see it. So the development of that pipe will be this way. So I'm going to assume this point is somewhere here. Yeah. That's how you do it. Freehand sketch, then you see the pipe. If this is the point of C, this is C. Yeah, changed it. That is the development of the pipe A. And then we say pipe A. 20 marks. Remember this question when it comes is 25 marks. To do interpenetration is 10 marks, you know, to get it right. Then to develop is another 15 marks. Then you get 25 marks. Whatever I've explained to you applies to hexagonal pipes and applies to square pipes and triangular pipes. Which means if this pipe here B was an hexagon pipe, let's say, okay, here. I'm just changing to hexagonal pipe. It's an hexagon, so this 4 will be a solid line. Can you see? 2 will be a solid line. It's an hexagon pipe. How was I going to develop B? I was not going to use circumference, no. You were going to come here and take the side length, you know, that side length. And you mark 6 times. You take any of that side length of the hexagon. And then you're going to mark 6 times, meaning that there won't be a line here. You're going to mark 1, then another 1, 2, you know, 3, 6. 1, 2, 3, 4, 5, another one, 6. So that on number 2, I'll just know that number 2 must come and meet with 2. And this was not going to be a curve, but a straight line. You are going to use a ruler to develop that. It was going to come like this, with ruler, you know. Why? Because it's hexagon. And we are going to outline these edges. If it was hexagon pipe, we are going to outline these edges. You see, solid. Because it was not hexagon, we are not allowed to outline. If it's a round pipe, we only outline the edges. But any other shapes, outline the edges, solid, and connect. Because if this is hexagon and this pipe is not round, I want to rectify. If this is hexagon and this is round, these won't be straight lines. These will still be curves, you see. Because there is a round pipe, this will be curved because of this round pipe joining to hexagon pipe, which I already told you even on the interpenetration, that hexagonal pipe to a round pipe is going to have a curve. But hexagon to hexagon or hexagon to square, they are not round pipes. Then you connect with the ruler. Am I making myself clear there?
Yes.
Yes. So these can't be straight lines because this pipe remains round. Only if I change maybe to a square pipe, then connect with your ruler your points. But it's going to be curves. And if this pipe was a square pipe, a standing pipe, this was not going to be set circumference. I was going to get the size of the square. You know a square if it was sitting like this. Let me draw here. If a pipe was sitting like that, if this pipe was a square pipe.
Sorry ma'am, you're below the screen there. We can't see you there. There's better.
Yeah. I'm saying the standing pipe, if this was not a round pipe but a square pipe like that, I would have only taken the side length of a square and mark 4 times. 1, the first one, 2, 3, 4. You see, 4 times. Why? Because it's a square, and then you need to know what is happening. Where are the A's and the B's and what? You still do the same. You need to know where they are falling on a square and come and mark them here and get that circle. But the time when we say circumference, it's only if it's round pipes. If there's no round pipe, don't do circumference. Take the side length of a shape, mark it. If it's 6 sides, you mark 6 times. This is 1, 2, 3, 4 sides. So it's 1, 2, 3, 4 faces. That's how it would have been if it was a square pipe. And a square pipe to hexagon pipe, interpenetration is straight lines. But a square pipe to a round pipe, you do the curve here on the development. Any questions? Wayne? Is Wayne in class?
No.
He left?
He was never on.
Oh,
today.
he didn't join?
No.
Okay, so it's only the Stan and you. Okay. Are there any questions?
No, I'm good.
Because I want to explain, there's like 15 minutes. I want to explain how to develop. Did I teach you how to do interpenetration of a cone?
Of what?
With a pipe.
Cone.
A cone with a pipe. Or a pyramid.
No.
But there's a video on Google Classroom. Did you check?
Not yet.
Okay, let me clean quickly. Maybe I can just see. You must check the video that is on Google Classroom. Because I can't do development if you don't know how to do interpenetration of a cone with a pipe. So what happens is that they'll give you, this is a cone joining with a pipe. I'll put green. Let's say this is a pipe coming to a cone. How do we know it's a cone? We are going to look here. There will be a top view given. Okay? The diameter from here to here, they are going to give you. I'll change the screen just now. It will be round. If they say it's round, then we know it's a cone. But if this is a square, sometimes it can be square, then it's a pyramid. So this is a cone because it's a round base. Okay? Then that cone is connected to this pipe here. Let's say the pipe is here. I'm going to just get it there. Yeah, that is the base of the cone here. This is the base of the cone here. You need to divide the cone in 12 divisions. 12 divisions. So let's say there's a division here. That. Like that. And there. Then this green pipe and that green pipe, they are equal in diameter. Though they don't look equal. Same diameters. Then you need to draw a circle here equals to the diameter of this circle. Then you need to draw a circle here or do a side view. Let me do this other method. I'm going to do a side view looking from this side of the cone. What are we going to see? we are going to see a cone this way. And then project this. Here you see a round green circle. Okay, this circle is in line with that one here. Can you see? Like that. Then divide this circle in 12 divisions. Yeah, 12 divisions. We start with 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, back to 6. Alright. Then, when you do this, when you do a side view of the connection, there is no need of you drawing a circle here. Are you understanding that? If you do front, side, top, do not come and draw a circle here. Instead, you are going to get the center line of the cone here and the center line of this cone here, and where they meet, draw a 45 degrees line for projection. You see this 45 line?
Yes.
Okay. So let's do that. I'll try to change this like that. So this is what the examiner is asking for in the exam. For interpenetration, he's liking now to bring the cone with a pipe. So because I've done the numbering, the first thing, he needs you to do interpenetration on the top view and interpenetration here. Then the next time I'll meet you, we'll come and develop a cone and a pipe separately. Today is how to do interpenetration of the two pipes. It's a conical pipe with a round pipe. So the first thing, we are going to start with the interpenetration here on the top view. This, even if I've divided the cone, in your mind, do you know that a cone is made like that with round circles at any point on a cone is circular, circular, circular. You know that.
Yes.
That's a cone. So, from the numbers that you have done there, you need to come with 0. This is number 0. Bring 0 here until where it hits there. You see where it hits there? Bring down. When it hits the cone here, bring the line straight down until the center line here. Because you know that the base of the cone is circular, at that point you are going to draw a circle from the center to here. Clear? But if this was having a square base, not round, I would have drawn a square there, parallel. I would have drawn a square like that. If this was a square, are you understanding me?
Yes.
There will be questions like that where it's a pyramid, but the base is a square. Then at each and every point you draw squares. If this base is hexagon, then at each and every point here you draw hexagon. So we are dealing with a round base. That's why I'm going to be drawing round circles. Why? Because it's round, 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 round. Not square, 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 square. The next one is division 1. This is 0, then 1. Project division 1. When it hits the cone there, bring your line down. When it hits there, come on the center and draw a circle. We usually do a semicircle, it's fine. Than drawing full circles, just draw a semicircle, it's fine. Then 2. When it hits there, bring your line down to here. From the center to here, you draw a circle. Then 3 is a midpoint. This is the midpoint here. There, you are going to draw, let me use green for you to see the difference. There is the center point. Okay? Then 4. 4, when it hits there, down to here. From there to there, you draw a circle. 5, it hits there, bring your line down to here. From there to there, you draw a circle. Then we go to the last one, 6. which is the bottom where the green point is, to there. Then you draw. Okay, so this one I'm going to increase a little bit. Yeah, the original. You see, we are doing that. Are we together so far? Now, to get the interpenetration here, once this is done, it's very easy. I'm going to those numbers. If I need the interpenetration of 0 there, I need to come to 0 and 6, you know, they're in the center. And 2, 8 hits 45 there. When it hits 45, you bring your line straight here from the 45, straight, and to where you hit the 0 circle. The first circle that represented 0 here, it's here. Okay? Then, number 1, there's 1 and 1 here, of which 1 is passing through 5. 1 is passing through 5. 1 and 5 together. When it hits there, bring your line here. And 2, 8 meets with 1 here and 5. This is 6, this is 5. Can you see? 5, 1.
Yes.
Also here it's 1 and 5 down. When it hits there, bring your line. Then you mark on the second one, which is 1, and then 5 there. This one here was for 0. Then we go to number 2. There is 2. 2 passing through 4. You come with a line 2 and 4. When it hits there, you bring your line here, which is 2 here, and which is 4 here. You go to 2 and 4 that side. Then you bring your line that way. Then it's 2 this side, and then 4 here. On the arc, that's where we mark. Then lastly, it's these 3, 3, 3. 3 is the outer part of a round pipe, so it must come straight there. Then project, and what was 3? When you project nicely, 3 will be on the green one, you know, the center. Just fix it, and 3 here to here. Then bring this line and 2 here on the green line. So it's green and green. Then 6. We did 5. 6 we didn't do. Where is 6? There is 6 here, and the last arc for 6 is here. 6 is in the center, and you find that 6 is here. Then you connect. This we are doing what we call the top interpenetration. We are looking from the top. The only piece that we outline is the top numbers. You see these top numbers? Here. It's from the center outline. Connect this freehand sketch. Solid. Then from here going that side is dashed lines. This is the bottom interpenetration. The bottom interpenetration is hidden line. It's at the bottom. But the top interpenetration is this left side of your drawing. Must always be solid. The right side of the interpenetration is dashed lines. Once that is done, from this point, which is the center line, to here, solid. From this point to there, solid. And then outline this pipe. Then the cone here will be dashed line. This part of the cone here will be dashed line. You see this piece here until there. Then it's a solid cone. From outside you will see. Why is it dashed line? Because it's this piece of the cone. You see, it's below. You won't see that piece of the cone. That's why I did the hidden lines. And then this one is not finished because we need the interpenetration on the front. Are there any questions on this one?
No, I'm good.
Okay, let's do the interpenetration on the front view and then we are done. The next time is to develop this type of interpenetration.
Okay.
To do the interpenetration on the front view, it's very easy because I'll use green. If I'm looking for 0, there is 0. There is 0 line. Where is the 0 point on the interpenetration? It's here. You remember this point.
Yeah.
Then you go straight with a line, straight. Already there's a line. Until where it goes to meet with 0 there. They meet here. Clear?
Yes.
We go to 1. There is 1, but 1 is with 5. We don't forget that. 1 is with 5. There is 1, and there is 5. 1 with 5. and there is 1. Where is 1 here? 1 is the next interpenetration. These two are representing 1. So when we draw, they will be at the same point. You see, there must be 1 up, 1 down. So use either the top 1 or the bottom 1. So if I use the bottom 1 here, then it's going to pass that way. Straight, straight, straight. Until where it meets 5, then I go straight until where it meets what? 1. You see where 1 is. Usually it's after this. Then you go to 2. 2 with a line of 2, then you come to 2 here on the interpenetration. Where was 2? 2 on the interpenetration was this other one. Then you go with 2 and 6. You see that 6 is this one here. With 2 somewhere there and another one there. Let me just do it straight nicely for you to see. I'll start with 1, 0, then its next is 1. Because this one is not accurate. The one that is accurate is this one. It's outside. So I'll use this one as 1. And then where they meet is here. So the bottom one is supposed to be somewhere here. But it's fine. I'll use that one. Then you go to division 2. Division 2 is going to be a bit out also. Somewhere there. You go out with division 2. And where it meets with 2 here, it's somewhere here. But it's 2 and 6. 2 and 6. This was 1 and 5. 1 and 5. 1 here, 5 at the bottom. 2 up to 6 here. As long as you take 1, 2, then 3. 3 is our center. Don't forget. I think after 0, the next line is 1, then 2, then 3. 3 is here. When you go with 3, it's the one with the center line. And then you get 3 here. Then we have 6. 6 was here. You see 6 was here. That was your 6. You go up with 6 until where you meet 6 here. When we come to 5, we said 1 is with 5. This is 1 and then it was with the 5. So you were supposed to come to that division of 5. Come up with division of 5 and get this point here, not that one here, that point there. 6, you come to 6. 4, this was our 4. You were supposed to come up here and get the interpenetration there. You see what you do. You use these dots. 0, 1, 2, 3, 4, 5, 6. Use those dots. Or 0, 1, 2, 3, 4, 5, 6. It's up to you. You work either with the top half or the bottom half. So if I need this 4, I'll go up. But when I look here, 4 is with 2. So I need to go with that line for 2, meeting with 4 and 2. And that is what you get there. Once that has been done, you just connect from 6 through 5, like this. You connect and then outline. Here it won't be outlined. That's how you get the interpenetration. Come to the number 0, go with 0. Point 1, straight up with point 1. Point 2, straight up with point 2. But if 2 is with 4, remember that you also have to go with 4 to meet the 4, you know, like that. That's how it's going to be. Clear?
Yes.
So, I know that it's recording. I'm coming next time to come and develop A and B. To develop the cone and to develop the pipe. This must be solid. And this interpenetration is solid. And the cone is solid. And then, for you to get, how much did I say? 25 marks. I think in the assignment, you saw this, did you? Oh, no. I'll upload the assignment here tomorrow. It's finished. There is a question like that in the assignment too. Any questions?
No, I'm good.
Are you okay?
Yes.
Yeah, and it's 3 o'clock on a dot. So I'll see you next week. You remember we are closing. Today is our last day. I'll be working from home. If there's a problem with my Wi-Fi, I'll be letting you know on WhatsApp, but I will be recording and sharing the recordings. You hear me?
Okay.
That's what I'll be doing. If there's a problem, then I won't invite you. I do the recording, then I upload on Google Classroom.
Okay.
Thank you, guys.
Okay, thank you.
Okay, bye.
Bye.